Okay, so this section is about shapes of distributions. So we can talk about the way data is distributed in terms of the shape that the data makes, whether it's on a histogram or a dot plot, or we'll see it also later in the chapter in box and whisker plots. So how the data is distributed. Okay, if we have a data set like this, where we have one sort of the highest piece of data, right, the biggest interval, is way over here, in this case to the right, and the tail, we call that the tail, where the data gets smaller and smaller toward the left. We say that data is skewed left because the tail is going to the left. Oh, hold on. I wrote it in. I'm going to erase this. I don't like the arrow going this way. I'd rather have the arrow going like this. The tail extends to the left, so we say that that is skewed left. The distribution is skewed left. Symmetric distribution means that both sides of the data sort of lead toward that central highest point or the central highest interval. It doesn't have to be exact. So it doesn't have to be like there's exactly the same exact number on both sides, but generally both sides kind of lead up to a highest point in the middle. Symmetric distribution can also sort of look opposite this, where maybe you have the high points on the ends, and then the data is distributed toward a low point in the middle. This is also symmetric. But basically you have a middle point that's either the highest or the lowest point, and on either side of that point, the data is fairly similar. Okay? Like I said, it doesn't have to be exact, but it's fairly similar. So the left and right sides of the graph mirror each other for a symmetric distribution. I'm going to erase that. A skewed right distribution looks the opposite of skewed left, where we have this highest point in our graph somewhere over here to the left, and the tail extends to the right. So the tail is going to the right from that highest point in our data, and we would call that skewed right. All right. So if you're asked to describe distribution, you're saying it is skewed left, it is symmetric, or it is skewed right. It's all about the tail. The way the tail extends is the way the graph is skewed. We're going to describe the shape by using one of those terms. Letter A, if we are going to describe the shape of letter A, the daily snowfall amounts on this dot plot, Miles, what would you say? Good. So we would say it is skewed right. Notice our highest point is here, this column, and our tail is going to the right. So we would call this skewed right.
That's crazy. I'm right.
Letter B. Now remember, we're talking generally. What is the distribution of the data in letter B? Dylan, what do you think? Symmetric. It is generally symmetric. If this is our highest point, generally the data is gradually sort of leading up and away from that on both sides. So we would call this a symmetric distribution. A symmetric distribution because on both sides we have a gradual leading up to that highest interval of our data. Okay, so it says display the data in a histogram. So you'll be given a table. For example, this is a table showing the number of people in a movie theater who are watching a comedy and their ages. So the first thing it's going to want to do is to have us, this is sort of piggybacking and building on what we did last week, to be able to draw a histogram. When we draw the histogram, it will be easy for us to see the distribution of the data and to be able to describe it. It's not as easy to see just by looking at the table, especially if the table's not in order. So let's start by drawing a histogram. Remember, the frequency goes up the left side of the histogram, and then we put our intervals along the bottom. Okay? So let's draw, sort of sketch a little histogram here. There was one person watching who was between the ages of 10 and 13. So that would be about here. 3 people between 14 and 17. 7 between 18 and 21. 12 between 22 and 25. 20, so then we go way up. And then 18, I'm going to sort of fall off here a little bit. I'm going to have to cover up my writing, but we can see the distribution, right? And then back down to 3 over here. When we put it into a histogram, we can very clearly see the shape of the distribution. Someone raise your hand, please, and tell me the shape of this distribution. Liam? Skewed left. Okay, this is our highest interval. And the tail of our graph is going to the left. So we would indeed call this skewed left. This histogram shows people watching a comedy in the theater. Let's look at the next slide. This histogram shows people watching an animated movie in the same theater, maybe just in a different room, right? Notice also, this is a side note, notice on a histogram, all of the intervals are touching one another. That was something I saw in the quiz. Make sure that your histograms, when you make them, the intervals touch one another, okay? They have to touch. That's part of the characteristic of a histogram.
Did you take off points if it wasn't touching?
I think I did. Yes. Not everything, but like a little bit. Okay.
When are we getting our test back?
Probably today.
Yes.
Okay. Here's what it asks. So it says this histogram is showing the animated movies, the ages of people in a theater watching an animated movie, and we're going to compare it to what we just saw, the ages of people watching a comedy movie. And then it asks us, which movie has an older audience, and how do you know? Which movie has an older audience, and how do you know? Kennedy?
The comedy movie has
Good.
an older audience.
Because why?
Because more people that were older watched it.
Right. Like, look at our histogram. Look at where our highest values were in the histogram of people watching a comedy. Because it is skewed left, it means the numbers, the bigger numbers, are more to the right. So there are more big numbers to the right. So we could say that generally the audience watching the comedy was 22 to 33 years old. That's where a lot of our big data points are. Compared to the audience watching the animated movie, our biggest data points, because how would we describe this data?
Skewed right.
Skewed right? Our tail goes to the right, which means a lot of our big data points are over to the left where the numbers are smaller. So the people are younger watching the animated movie. So if we were answering the question, which movie has an older audience? We would answer the comedy